All right, today's lesson is probably one of the more important ones in Chapter 3 because once we're familiar with function notation, we will be using it the rest of the year. So what is function notation? Function notation is another name for the y value of a function. It's read as f of x, and it looks like f with x in a parentheses. So this means the function of x. You can use other letters instead of f. So the second example, h of x, is another function of x, but the function is h. Or g of x is another function of x, but the function is g. So let's see an example of what this looks like. The first function, the function of x, is negative 4x plus 7. We're going to evaluate it for when x equals 2 and x equals negative 2. Notice f of x equals negative 4x plus 7 kind of looks like how we've read y equals negative 4x plus 7. So f of x replaces the y value. And in the first part, we're looking at the function of 2. Notice 2 replaced the x. So now we're going to replace the x with 2 in the function. So we have negative 4, 2 plus 7. We're going to solve that. Negative 4 times 2 is negative 8. Negative 8 plus 7 is negative 1. So f of 2, when x is 2, y is negative 1. All right, now let's look at the function of negative 2. So now we're going to replace x with negative 2. And now we have positive 8 plus 7, which is 15. So the function of negative 2, when x is negative 2, y is positive 15. All right, for example 2, we're going to look at interpreting function notation. So f of t is going to represent the outside temperature t hours after 6 a.m. So let's interpret what each of these mean. F of 0 equals 58. That means 0 hours after 6 a.m. the temperature is 58 degrees. So at 6 a.m. it's 58 degrees Fahrenheit. All right, f of 6 equals n. That means 6 hours after 6 a.m., it's n degrees. So at 12, at noon, it's n degrees. All right, part C, f of 3 is less than f of 9. That means 3 hours after 6 a.m., the temperature is less than 9 hours after 6 a.m., or at 9 a.m., it's colder, because I know if the temperature is smaller, that means that it's colder outside. Then at 9 hours after 6 a.m. would be 3 p.m. So at 9 a.m. it's colder than at 3 p.m. All right, so we looked at evaluating a function for x. Now let's look at solving for the independent variable when we know what the function should equal. So in part A, I have h of x equals 2/3 x minus 5. We want to find the value of x when h of x is negative 7. When h of x equals negative 7. That means I'm going to replace h of x with negative 7. So I'm going to rewrite this as negative 7 equals 2/3 x minus 5. And now we're going to solve for x. So add 5 to both sides. Negative 7 plus 5 is negative 2. Now I have negative 2 equals 2/3 x. To solve for x, I'm going to divide both sides by 2/3 or multiply by 3/2. If I multiply negative 2 by 3/2, I'm going to get x equals negative 3. You could also use a calculator for that last step. But we solve for x equals negative 3. That's my answer for part A. So part B, I have f of x equals 6x plus 9. I want to find the value of x when f of x equals 21. So we're going to replace f of x with 21. So I'm going to write 21 equals 6x plus 9. Now we're going to solve for x. Think back to everything we learned in chapter 1. How do we solve for a variable? We want to get the variable by itself. We're going to use GEMDAs backwards. So what step do we do first? We subtract 9 from both sides. We're using the inverse operation of addition to undo it. Cancels out on that side. 21 minus 9 is 12. So now I have 12 equals 6x. Now how do I solve for x? I divide both sides by 6. 12 divided by 6 is 2. So I have x equals 2. All right, example 4, graphing a linear function in function notation. I have f of x equals 2x plus 5. Remember, I can think of this as y equals 2x plus 5. Just a little side note. So we're going to create an input-output table, then we're going to plot the ordered pairs, then we're going to draw a line through the points. So input-output table, I'm going to have x is my input, and then f of x goes where y would normally go, that's our output. So for x, some good numbers to always plug in are -2, -1, 0, and 1. That way you can see what the y-intercept is, and you can see if there's a difference between the negative and the positive inputs. All right, so if I plug in -2 for x, I have -4 plus 5, which gives me an output of 1. If I plug in -1 for x, I have -2 plus 5, which is an output of 3. If I plug in 0 for x, I have 5. Notice a pattern in the y values, 1, 3, 5, 7, 9. All right, now pause it for a second and plot those ordered pairs on the graph. All right, my ordered pairs are plotted. Last step, we're gonna draw a line through the points. Now, if you're working in Notability, there's that fancy way to make a straight line where you hold the stylus or your finger, whatever you're using, and it automatically makes it a straight line. So you can do that in Notability. If you're drawing on your notebook, you can use a ruler to make it straight. I won't judge your notes, so it doesn't have to be perfect, but draw a line through the points, and there is our function. All right, if you're doing notes in class, this is where we're going to stop and have you try to graph it by yourself. If you're doing this on your own at home watching the video, pause it, see if you can graph 3x minus 4 all by yourself, and then check it to see if you got it correct. I'm going to go ahead and solve for 3x minus 4. So first step is to create an input-output table. I have x and I have h of x. We're going to use -2, -1, 0, 1, 2. If I plug in -2 for x, I have -6 minus 4, which gives me an output of -10. If I plug in -1 for x, I have -3 minus 4, which gives me an output of -7. If I plug in 0 for x, I have -4. 1, I have 3 minus 4, which is -1. Hopefully you've noticed a pattern, -10, -7, -4, -1. Next one is 2. All right, then we're going to plot these points. I have -2, -10, 7, 4, 1, 2. And last step, draw a line through the points. There is our function. All right, and we'll wrap it up with some summary questions. What is function notation? That is when a function is written as f of x. It's read as f of x. It's written with parentheses. How does it relate to the y value? Well, it replaces the y value. Normally we would have y equals mx plus b. Now we have f of x equals mx plus b. If I'm given a problem where I need to determine the value of f of 3, what are the steps I need to take? F of 3 is where you plug in 3 for x. On the opposite hand, if I have f of x equals 3, that's when you plug in 3 for y. So f of 3, plug in 3 for x. If f of x equals 3, plug in 3 for y. How do you graph a function? Well, we're going to graph it the same way we would as if we were still using y. So make an input-output table, plot the points, connect the dots. How do I determine which values to use? We're going to start with always using -2, -1, 0, 1, 2.